In the first part of this tutorial on multi-criteria decision making, we saw how to generate a matrix with a good number of candidate points that cover all our experimental field to be used in this second step to make predictions of different responses that we are interested in, and after this prediction we'll use this data to perform a Pareto front analysis to decide to define the final process conditions. So we obtained this grid, this matrix that is called CP, candidate points, that is composed of all the possible combination of the different variables at the level that we selected. So for the first variable we selected only one level, 0, that is the solvent. For x2, that is temperature, from 35 to 45 we selected 11 levels spaced by 1 degree. And for the base, x3, we have 7 different levels from 1.0 to 1.6 that were the -1 and +1 points spaced of 0.1. One comment about the spacing that we selected. It is clear that the spacing could be even smaller. We could select 0.1 for temperature as step, but it is clear that this space, this step, should have an experimental meaning, and so it is clear that probably it would not be possible to differentiate and to perform experiments with a difference in temperature smaller than 1 degree. And when we select this number of candidate points, we should take into account the experimental meaning of the numbers that we select. As we know, to perform and to use this matrix in a DOE, in a model computation or in a prediction, we need to transform this data in the -1 +1 coding, because the software accepts only this encoding. We can do this, of course, manually, but there is also a function in CAT that does this. So we go in this tab, transformation, we select column, because we want to transform 2 columns, and we select the -1 +1 transformation. The matrix that should be transformed is CP. The column that we want to transform are 2 and 3. We give OK, and a new matrix that is called cp.cod has been generated, and we see here that the matrix is now composed of combination and candidate points expressed with the -1 +1 encoding. At this point we can use this matrix to perform the prediction. First of all, we'll predict the values of the conversion response for these points. First of all, we need to calculate the model on the original CCD2 matrix that we saw before, so that that model will be then applied to the candidate points in prediction. So the matrix is CCD2 that we saw at the beginning. All the rows, the variables are at columns 1, 2, 3, and the conversion response is at column 4. We use higher terms and intercept. Okay. We use the residuals, and then the model has been calculated. Now we go again in the tab MLR DOE, and we go in the prediction tab. prediction. The experiments to be predicted are now contained in the matrix cp.cod. We want to predict all the 77 experiments. The variables are in the columns 1, 2, 3 that we encoded before. We give OK, and then we have here a new matrix var.pred that contains in the first column in particular all the predicted values for the 77 candidate points that we selected before. We'll repeat this process for all the 4 responses that we want to evaluate, and on which base we want to perform then the decision on the final experimental condition to be used for the process with the Pareto front analysis.